Hey, grade 11s. We've been talking about the mole and different ways we can measure it. We know that the mole is a grouping. It's a grouping that contains 6.02 times 10 to the 23rd particles. So 1 mole is equal to that many particles. But that wasn't a very convenient way to measure it. It's just more of a definition of what a mole is. If I want to measure a mole of a substance, we found out that the mole, 1 mole of any substance, is equal to its molar mass in grams, and also that 1 mole of any gas would occupy 22.4 liters of volume at standard temperature and pressure. These are our 3 truths that we have available to us when we convert between moles. But can I convert directly from liters to particles or from particles to grams? You'll notice that in this picture, there is no direct link from grams to liters to particles. All of these things, in order to go from one to the other, must first be converted into moles. So this little diagram that kind of looks like an upside down Y is a quick way for us to think about if I'm given one of the outline factors, if I'm given mass or volume or a count, how can I convert it into any other of the 3? Let's take a look at an example or two. How much mass, for example, would I have if I had a container that had 44.8 liters of methane? Now, we're given liters, so we always start with what you know. You notice where liters is? Liters is here, and we have 44.8 of them. But they want us to get to grams, and grams is mass, so we want to get here. Following our picture, we're going to change first liters to moles using our number of 22.4, and then we're going to change moles into grams using our molar mass. Now, you can do this one step at a time, or you can do this in one fell swoop. We can use the same 4 steps that we've been using all along. Start with what you know. We know 44.8 liters. We then put the units we're trying to get rid of on the bottom. First thing I want to get rid of is the units liters, so we'll write them there, and put the units I'm trying to solve for on the top. Remember, the first step in our journey is to go to moles, so I'll write the word moles on top. Now, the numbers that make liters to moles true is 1 mole is 22.4 liters. So beside the word moles, I put the number 1, and beside liters, I put 22.4. At this point, liters on the top would cancel liters on the bottom, and I'm at moles. But we're not done yet, because we also now want to get rid of moles. We're trying to get to mass, and mass is in grams. So again, I'm going to put the units I'm trying to get rid of on the bottom. I'm going to write the word mole on the bottom, and the units I'm trying to solve for on top. I'm trying to solve for grams. Now, what's true about moles and grams? Well, in the case of methane, if I look at my periodic table, we can see that carbon weighs 12 grams for every 1 mole, and each hydrogen will weigh 1 gram for every 1 mole, but of course we have 4 of them. So we're going to have 12 plus 4 is 16 grams per mole. That's the molar mass for methane. We're now going to cancel moles on the top, we'll cancel moles on the bottom, and the units that we remain with are grams. And as long as we've canceled out all of our other units, and the unit we're solving for is the remaining one, we've set this up correctly. Again, as long as we multiply all the numbers on the top of the line and hit divide in front of all the numbers on the bottom of the line, we'll get to the correct answer. 44.8 divided by 22.4 times 16 is 32. Because the only units we haven't canceled is grams, we'll have 32 grams. 44.8 liters of methane weighs 32 grams. We can do this with any 2 outlying points. Suppose that we're given a sample of oxygen gas and we can tell that it weighs 64 grams. We're going to start here at grams. We're going to start with the 64 grams. We want to find out how many molecules there would be in it. And molecules is over here. This is my number of particles. Again, there's no direct connection between grams and the number of particles. I will first have to change grams to moles using my molar mass, and then I'm going to have to change moles to the number of particles using Avogadro's number. Starting with what I know, the only number given in the question, I'm going to start with 64 grams. Because I don't want the units grams in my final answer, I write grams on the bottom, and I'm changing it first to moles, so I write the word moles on top. So our truth is always 1 mole of this substance weighs how much? Oxygen on our periodic table weighs 15.99. For our purposes today, we're going to just round that to 16 grams in every 1 mole. But it's O2, oxygen's diatomic, so we'll need twice as much. 1 mole of oxygen molecule will weigh 32 grams. See how grams on the top cancels grams on the bottom? We're at moles. At this point, if you want to solve 64 divided by 32 and get 2 moles, you're welcome to do so. But I like to just continue right along. Let's just cut this off again. I don't want moles in my final answer, so I'm going to write the word moles on the bottom. I'm trying to change it to molecules, so I'm writing the word molecules on the top of the line. Moles on the top will cancel moles on the bottom, and that'll give me an answer in molecules, which is what I want. 1 mole of any substance contains this many particles. It doesn't matter whether those particles are atoms or molecules or donuts. A mole is just a unit of how many. So 1 mole is 6.02 times 10 to the 23rd. Again, multiply your numbers that are on the top of the line, divide if your numbers are found on the bottom. 64 divided by 32 times Avogadro's number gives me 1.204 times 10 to the 24th molecules. 64 grams of oxygen would have a lot of molecules present. What we're going to practice for a day or two is whether or not you can perform 2- and 3-step conversions between moles, grams, and liters, and the number of particles. Remember that if we're given grams, liters, or the number of particles, you must always convert it first to moles. This is an important skill, and it's one that you're going to use continuously all the way through grade 12 chemistry and also into university. Converting between the number of representative particles is important for understanding what a mole is, but practically converting between moles, grams, and liters will be a skill that you will use over and over again throughout your career in chemistry. In your stoichiometry work packages, there's practice on these 3-step conversions on pages 35 and 36. The chart on page 36 sometimes makes it seem like you could do all these questions in your head, especially with the first one being basically just a definition of what the truths are between grams, moles, and particles. However, it's more of just a place to organize your answers. You will still have to draw a little factor label sign to solve for each and every blank in that chart. Remember, take your given value, solve for moles first. Once you solve for moles, use that amount to do all other conversions. We can only find liters or grams or the number of particles if we first know how many moles we have.